Hi, Calculus. Sorry that I can't be there with you today, but I didn't want to leave you hanging. So instead, I created these videos for you that are basically going to take you through the whole lesson that we would have been doing in person, but instead, we're just going to do it through video. So, two things before I begin. So, first thing is that as you're watching the video, if you come across questions that you have, I want you to write those down, circle any problems that are still confusing to you, and I will try to go over all of those when we're together next class. At the end of today, I'm hoping that you'll fill out a Google form as well that will give you an opportunity to ask me those questions, so that way I can prepare a lesson for you when we come back to class together on Monday, so that way I can answer all of those questions. Second thing is that throughout this video, or these videos, I'm periodically going to be talking about, or I'm going to say, pause the video here and try the problem on your own. So when I say that, I say it because I actually want you to try that, okay? The only way that you're going to get better at calculus is if you're actually practicing, right? You're not here to just copy the notes and have it go in one ear and out the other, right? You're here to actually try and actually learn. So pause the video when I say pause the video here. Give each question that I'm talking about a try and see if you can do it, okay? This is going to be a somewhat long lesson, so stick with me as I go through everything. I'm going to try to be as descriptive as possible, but we also have a lot to get through, so stay with me on this, okay? So on this first page, you'll just see what you normally see every day. Here's our topic for the day. We're going to be talking about derivatives of inverse functions, and that includes inverse trig functions. It's Throwback Thursday, so at the end of today, you'll have some throwback questions on Albert. Now, for today's agenda, my goal, and this is when I'm just starting, so this might be different, but my goal is to condense today's lesson into 3 short videos that are going to be 15 minutes or so. And then at the end, I'm going to have you do an exit ticket that is using a Google form, and then also answering some questions on Albert to show that you've actually learned the material that you've learned today. If you are unable to finish today's lesson during class, then watching these videos outside of class, filling in your notes is going to be your homework, okay? You can work with one another while watching these videos to try to understand, talk about the material, whatever it is that you need to do to be successful. All right, and as a reminder, you have your mid-unit quiz on the 30th, which is next Wednesday. Okay, so keep that in mind. Okay, let's go ahead and begin the lesson. So we are an inverse function, so I'm first going to go over a review of Algebra 2 and pre-calculus on what inverse functions are. Okay, so for the definition of an inverse, so we know that 2 functions, f and g, are inverses of each other if when we take the composition of them, we get x, okay? So the composition of f of g of x and g of f of x, okay? And we write our inverse functions by f with the little -1, f inverse. All right, important to know is the reflective property of inverse functions. So if the graph of f, the original function, has the point AB, then the inverse function has the point BA. We switch the x's and the y's. Very important when thinking about inverse functions. Okay, switch the x and y. All right, so let's do some practice with this. So we have a table, shows us x values, f of x, and g of x values. Now, when we're thinking about our functions, right, normally we can think that f of x, that would be the same as the y, right? And g of x, that's also the same as the y, if we're putting in this x, right? X and y, x and y. So now, the green, that's for if we have just f of x or g of x. However, let's think about the inverse functions, right? In inverse functions, we switch the x and the y. So for our inverse function, these y's are going to become the x's. Okay, so I'm going to write the x's here, right? And this x then becomes the y. Now, I'm going to write the y as, instead of just y, as f inverse of x, right? Of the red x's. So this is the x, these are the x values we put in, get our inverse, or g inverse, okay? So this column is the same for both of them. All right, it's hard to write with this. Okay. Right, so we just switch our x and the y, okay? All right, it's going to be super important, so you gotta know that. So let's complete our table of values for part A. So we're looking at, given some x values, what do we get out for the output? Now here, So we got to think, if we're looking for the inverse function, right? What values of the inverse do we know? Oh, well, we know 3 and -1, right? And what would be the x values associated with that? 2 and 4, right? Now for b, so what are the output values that we get for g inverse? Well, that would also be 3 and -1. And what are the inputs for that? We go over to this column for g of x, and that's really our x values for the inverse. So -1 and 3. All right. So now let's move on to part C. So find the value of f of g inverse of 3. So we got to think, what is the question that we're looking for here? Well, what we're really looking for is if we were to plug in 3 as our x value into the inverse function of g, what would we get? Right? Because this is composition. We got to start with the inside function first, then go to the outside function. But anyway, g inverse of 3. So 3 would be our x value for the inverse. So right here, 3, and our output that we get would be -1. Okay, so that's one way of thinking about it, but I also want to think about it in a different way. Okay, and what might help with derivatives of inverse functions is thinking of a different way to think about this. So we can say that either we're looking for what happens when we put in an x value of 3 into the inverse function. What do we get out? It's -1, right? Or we can think, oh, okay, 3, what is 3 equal to? It's actually equal to g of x. So the other question we can ask ourselves is, when does g of x equal 3? For what x value? And then we come back over here and we look, oh, it's -1. So then we plug in -1 into f. F of -1 is what? 4, right? Okay, let's do d. So we start with the inside function for composition. What is f of -1? Got to go up here. F of -1. We plug in -1 for x. We get an output of 4, right? Oh, ignore that. That's not right. We get an output of 4. And then we're looking for what is the inverse function of 4? Now the question that we want to ask ourselves here is we want to switch it around. And we want to ask, when is f of x equal to 4? Okay, so always switch it and ask yourself the other question. When is f of x equal to 4? Well, we look back up here. F of x is equal to 4 when x is -1. Okay? All right, so let's try E. G inverse of -1. So what's the question we're asking ourselves? We're asking, when is g of x equal to -1? Right? Going back up to our table, g of x is equal to -1 when x is 3. So we go back down here, plug in 3. Now we have f inverse of 3. So what's the question? When is f of x equal to 3? When is f of x equal to 3? Oh, wait, it's not there. So, therefore, it is undefined. Okay? All right, and one more, practicing these inverses. So let's look at f. F inverse of 4. What are you asking yourself? Actually, go ahead and pause the video here. Try to see if you can solve this one. All right, so hopefully you pause the video. If not, pause it again and try the problem. All right, so we're starting with f inverse of 4. That's asking, when is f of x equal to 4? And that's at -1, when x is -1. Now, g inverse of -1, we're looking for, when is g of x equal to -1? And that is at 3. Okay, so hopefully you were able to get that. Okay, moving on to more calculus. So that's your review of Algebra 2 and Pre-Calc. Now let's add in calculus. So first of all, calculus helps us to prove the existence of an inverse function. So 2 ways that we can do that. Number 1, you have to know a function has an inverse function if and only if it is 1-to-1. Now what does 1-to-1 mean? That means for every x value we have only one y value, and for every one y value we have only one x value, right? So no, parabolas are not 1-to-1. You can also use your horizontal line test to determine if a function is 1-to-1. If it passes the horizontal line test, it's 1-to-1. All right, so number 2 is saying if f is strictly monotonic on its entire domain, meaning either it's increasing or decreasing on its entire domain, then it is 1-to-1 and therefore has an inverse function. Okay, now I want you to underline a part here. Let's underline either increasing or decreasing on its entire domain. That's the important part here, okay? So what we use this for is we can prove that a function has an inverse function or that it's one-to-one by showing that it is either increasing or decreasing on its entire domain. So let's think about what that actually means, though. What does it mean for a function to be either increasing or decreasing on its entire domain? Well, let's actually write this up here. This is going to be super important to have. Okay, so what does that mean? That means that if it's either increasing or decreasing, then the slope is either positive or negative on the entire domain. And how is slope important to us for calculus? Well, because it's all about the derivative. So I'm going to type this in here. So you guys should probably type this in too. All right. So if the derivative is greater than 0, I'm going to replace the slope. I'm going to replace the slope with the derivative. Okay. So if the value of the derivative is either greater than 0 or less than 0 on the entire domain, it is one-to-one and has an inverse function. I'll move that so you can see it. All right. So, let's make it smaller. Okay. All right. So if the value of the derivative for an inverse function or for any function is greater than 0 or less than 0 on the entire domain, it is one-to-one, has an inverse function. I've actually seen AP problems like this where they've asked you to prove that a function is one-to-one or prove that it has an inverse. Now to do that, this is what we would do. You would find the derivative and prove that it's either greater than 0 for the entire domain or less than 0 for the entire domain. Okay? We'll have a problem like that in a bit. Okay, but let's move on. Whoops, don't look at that. You should not be seeing that yet. All right. So here below, you'll see we have the relationship between a composite function and its inverse. So f of f inverse. So it's the composition of the functions, right? We're going to use the chain rule to differentiate this so that we can find the derivative of an inverse function. That's our goal for today. How do we find the derivative of an inverse function? Okay, so taking the derivative, what would we do? Well, we have f of f inverse of x. This is the chain rule because we have our outside function, which is f, and we have our inside function, which is f prime of x, or f inverse of x. So taking the derivative, we start with what's the derivative of f? Well, the derivative of f is f prime, right? We keep our inside function, which is f inverse of x, right? So that's our first part. Then what's our last part of the chain rule? We have to multiply by the derivative of the inside. So to denote the derivative of f inverse, this is how we do it. All right, f inverse of x and this little slash on the outside to denote that it's the derivative. And then we take the derivative of x, which is indeed 1. Okay. Now we're solving for what is this derivative of the inverse function. And so to do that, all we have to do is take the 1 and divide it by this mess, right? The f prime of f inverse of x. Okay. So you just found the formula for taking the derivatives of inverse functions. Now, I'm going to caution you here and stop you here. We have this formula right here, right? Super lovely, great, super helpful. But I will caution you. I think that even though we have learned this formula, it can be a little bit confusing. So instead of memorizing this formula exactly, I think it might be easier to memorize the steps that you use in solving for the derivative of an inverse function. Okay? So I'm gonna go through those steps in a couple minutes. In the next video, actually, because I'm going to stop the video here. But try to memorize these steps, okay, rather than trying to memorize the formula exactly. Okay? All right, so real quick, I'm going to go through this next example, and then I'm going to pause the video and move on to the next one. All right, so here's your example. Given the function f of x is equal to 4x minus 3 and f prime of 2 is equal to 4, so our derivative at 2 is equal to 4. We want to find the value of the derivative of the inverse function at 5. All right, here we go. This is what we got to do. First step, we want to know what is this f inverse of 5 actually asking? Well, if we think back to the previous page and what we did on the previous page, my video's opposite of you guys. If we think back to the previous page, f inverse of 5, what does that actually mean? Well, that actually means that we're looking for when does f of x equal 5. So we just plug that in for f of x and solve for our x, right? So 5 is equal to 4x minus 3. So that means that 8 is equal to 4x, right? Because we add 3 to both sides. So x is equal to 2. Okay? All right, good. So now that we've found what our x is, we found what f inverse of 5 is, right? F inverse of 5 is equal to 2. So now we're going to go back here, and we're going to plug that in, take 1 over the derivative at that number, 2, right? And then f prime of 2, we know from the original problem, is equal to 4, so therefore our answer is 1/4. Okay, so two or three steps in that, right? First step was we found, let's use red. We found, we solved for the inside, right? So what is the inverse of 5, right? We solved all the way down for our x, so this is the whole first step. Then our second step was we just plugged that into 1 over the derivative of that number. That's it. 2 steps. Okay. All right. So I'm going to pause the video and then move on to the next video where we go more in depth with this and show more examples.